Okay, so this is going to be the solution to what is this, the 24th problem in the grind 75. This is maximum depth of binary tree. So basically what the maximum depth is the number of nodes from the root to the leaf that is the farthest down. And there's two ways that we can calculate this. One is to calculate as we are going down. So from 3, maybe recursing here, getting this height, recursing down here, maybe getting that height. Or we could recurse all the way to the bottom, and as we go up that recursive stack, we add the height. And that's the way that I did it actually, and that's probably the one that's simpler to implement. I actually made it a little slightly more complicated than it had to be, just by putting the logic in an extra function, but it's completely unnecessary. And it literally only takes like 4 lines. So first off, if we have, it's possible that we can have a tree with 0 nodes. So if root is equal to null, then we know that we have a depth of 0. And from there, all we're going to do is calculate a left height by recursively calling this function max depth on root dot left, and similarly calling it on the right. And then from there, what we return is 1 plus the maximum of these two heights, the left height and the right height. And if we go through this algorithm, we can see that, say we have this tree right here. We call left by evaluating what's to the right of the equal sign, and then we get down to here. Root is still not equal to null, so then we're going to go down to each of its children. Those are going to be null, so we're going to return a value of 0. And once we get here, because 0 has been returned here, we're going to return 1 plus that. And then we're going to go up there. And I mean, the same process is true. I was just illustrating. Same process is true for the right side. So yeah, we can just run test case, make sure there's no syntactical issues, but yeah, that's really all there is to it. That is the bottom-up approach. Really quick, just for my sake, I also want to implement the top-down approach so I have an understanding of it. So for this, we have to create a variable. We can call it anything. We can call it, let's just call it max height. And for now, it's going to be initialized to 0. Now we are actually going to have to create another function. This one is going to be, this one can be called DFS, as in depth first search. And we're going to pass in the tree node, the root, and then an integer called count. And that's going to basically, we're going to increment that as we recurse down the tree. And so what we're going to do actually is call left height actually we're not going to do this up here, we're going to do this pretty much all in here. The first thing we're going to do is actually, I'll get rid of this. We're going to pass in our original root to DFS. So DFS, we're going to pass in root, and then we're going to pass in a count of 0. And then we're going to say, have our base case. Now if root is equal to null, then we can return 0. Otherwise, what we're going to return is the maximum of recursing down left using this DFS on left, so root dot left, and then incrementing count like so, and then doing the same this time on right, and also incrementing count. Okay, so return 0. This would not actually be necessary right here. We also, I believe that's all that needs to be done. Do we need to keep track of max height? Let's see. Let me think about this. So max height is initialized to 0. We can just return whichever yields the maximum. One of these trees will have the maximum, because if we're looking at this, you know, this tree will automatically get its maximum height. Same for this tree. So I believe this is actually all that needs to be done. And maybe we can say int max height is actually equal to that. And let's see if that works. I think there might be something I'm missing. We might have to add a +1, because I think right now we're just getting, we're going to be doing +1 and +1, but really we need to get the number of nodes. So we might have to return an extra +1, so we can return maybe max height +1. Let's see if that works actually. Output is 1. Let me pause for a second. Okay, so we actually have to think about this in a slightly different way. So we do need that global variable. We can call it max height. Let's see. This will just be called result right here. This should also just be called result. And basically, this is always going to return 0, because we're basically just going down the tree and then returning 0 once we hit a null node. But what we want to return is the count that we've been adding up as we've been going. So the way that we accomplish this is by doing the following. So we don't need the maximum of that. We actually just need to traverse down the left and the right, like so. However, once we get to a leaf node, then we want to see if its answer is, or its depth is greater than our current max height. So we can do so by doing math.max. Let's see. So this would be the case if we get down to a leaf node. So that means if root.left and root.right are both equal to null. Then we're going to compare the current count to max height. So max height is going to be equal to either itself if it's greater, or our current count if that's greater. And I believe this should work. 0, return result should actually be returning max height. This doesn't actually return anything. Well, it returns, we don't need to return anything there, because say we count 1. We go down right, that's another count 1. Go down here, that's another count. And at this point, we are going to update max height with the count that we have at this leaf node. But we will continue the recursion until we get to this leaf node's null children. But at that point, we don't want to be adding to our height. We just want to return out of this function. So this should return the appropriate value, and let's just run the test case. Okay, yeah, that's why is that wrong? Void cannot be converted to int. Okay, yeah. We are just calling this function. Okay. All right, and so that has been the top-down approach to this problem. The bottom-up was a little easier for me. It was what I jumped straight to, but I think it's good to know both approaches depending on what problem you're given. So that's been the 24th problem in the grind 75. That's the solution.